let's learn how to find logarithm of numbers from indices and standard form. Here you'll be needing your logarithm table, so you might want to get that beside you. Now we have to find the logarithm of the following numbers. The first one, solution. A. We have 3.701. Now the first step is to express the number in standard form. 3.701 is going to give us 3.701 times 10 raised to the power of 0. Recall that 10 raised to the power of 0 is 1 and 3.70 times 1 will give us 1. And standard form means we are to express the number in the form a times 10 raised to the power of n, where a is a number between 1 and 10 and n there is an integer. Looking at this number, we've successfully done that because 3.701 is between 1 and 10 and the 0 we have here is an integer. Then we'll move on. Now we express 3.709 as 10 raised to the power of a particular value. 10 raised to the power of what will give us 3.701, and that's where our logarithm table comes in. The logarithm table you have is logarithm of numbers in base 10, and the table is like this. You have x, you have digits ranging from 0, 1 to 9 at this side. Then here at the top you see something like difference. Then also you have 1 to 9, digits ranging from 1 to 9. Now for us to find the value the value we are having here, that is the power 10 has to be raised to give us 3.701. That means you have to look for the logarithm of 37 under 0 difference 1. We pick the first two non-zero digits, then followed by the two digits that follows. Now here, the numbers you are having here, you are having 10 to 99. So to read the logarithm table, you go to 37, which is in between 10 and 99. Under 0, you should have 5682 under 0. Then the difference of 1, we have a value of 1 here. So to find our logarithm, we add up the difference with the value we have here. That is 5682 plus 1, we have 5683. So that means the logarithm of 3.701 is 0.5683. So we come back here and write it out. 0.5683. Then times 10 raised to the power 0, which is 1. So we can just leave it like that. Now we can now write out our log. Log of 3.701, which is the same thing as having log to base 10 of 3.701. Recall in the previous video I said whenever you have logarithm without any base like this, it is usually in log 10, in base 10. So here, this is the same thing as having log to base 10. 3.7 has been expressed as 10 raised to the power of 0.5683. And that means the logarithm is the power, what we need from the definition in the previous video, 0.5683. And that gives us a logarithm for 3.701. Now the second one, 37. Following the same procedure, express this 37 in standard form. To express it in standard form, that means we are expressing in this form. So that means we'll be having 3.7 times 10 raised to the power of 1. Then after doing that, express 3.7 as a number with base 10 and a particular power. So, and that's going to give us 10 raised to the power of, since we've gotten 3.7 here as 3.7, 37 under 0, we have 5682. Times 10 raised to the power of 1. And applying law of indices, this becomes 10 raised to the power of 0.5682 plus 1. Why? Because under law of indices, we have h raised to the power of a multiplied by h raised to the power of b equals h raised to the power of a plus b. And here we have 10 raised to the power of 1.5682. So the logarithm of 37 becomes equal to the power that we have here, 1.5682. Now for the third question, see, we have 37,000. Here the first step is also to express this in standard form. And to express this in standard form is going to give us 3.7 times 10 raised to the power of 1, 2, 3, 4. 10 raised to the power of 4. And 3.7 can be expressed as 10 raised to the power of 0.5682, then multiplied by 10 raised to the power of 4. Now by applying law of indices, this becomes 10 raised to the power of 0.5682 plus 4, which gives us 10 raised to the power of 4.5682. And the logarithm of 37,000 becomes this power that we have here, 4.5682. And that's how to find the logarithm of numbers using indices and standard form, and also the logarithm table. Thank you.